let's try to solve this problem here. So you have 2 point charges of opposite sign and the same magnitude, which is 2.0 times 10 to the power negative 7 coulomb, and they are separated by a distance of 15 cm. Okay, they did not say the two charges are in the same x-axis, or they are in the y-axis, or they are slanted, or they are front back. They don't tell you the orientation of the charge. They just tell that the distance between the 2 point charges is 15 cm, and if one is positive, the other one will be negative, but the magnitude should be the same, which is 2.0 times 10 to the power negative 7 coulomb. So that is a situation. And if you look at the situation, they ask you to find the magnitude and direction of the electric field strength at the midpoint between the charges. So between the first charge and the second charge, the midpoint over here, what is the electric field strength at that position over there? Okay, the second question they ask, what is the magnitude and direction of the force on an electron placed at the midpoint? So if I place an electron at the midpoint, what will be the magnitude and the direction of the force experienced by the electron? That is what the question asking for. Okay, so let's try to draw a situation. Okay, since they don't mention that the two charges are lying on x-axis or y-axis, so we shouldn't assume that it's in the x-axis or in the y-axis. So what I usually do, right, is I will try to draw it at a more peculiar orientation. I will try to do it in a straight line. So I'll take one to be over here, another one to be over here. Okay, so I'll draw a dotted line in between them, and the distance between them will be 15 cm, 0.15 meter. Okay, so if I call one to be positive charge, then let's call this one as Q1. So Q1 will be 2.0 times 10 to the power negative 7 coulomb. Whereas Q2 over here will be negative 2.0 times 10 to the power of negative 7 coulomb. It's important to highlight the negative over here. Okay, so this is the situation that we have right now, and they now ask you to find the magnitude and direction of the electric field strength at the midpoint. So the midpoint is over here. This is what we call the midpoint. So over here, there will be electric field, but the electric field is produced by what? Well, you see there's 1 point charge Q1 over here. So Q1 will produce an electric field around Q1. So midpoint is a position that is around Q1. So midpoint will have an electric field that is produced by Q1. Okay, at the same time, Q2 is also a point charge. So Q2 will produce an electric field around the position of Q2. So since midpoint is just beside it, it's around the position of Q2. Therefore, the midpoint over here should also have electric field produced by Q2. So at this midpoint over here, there will be electric field produced by Q1. There will be electric field produced by Q2, and they both overlap at the midpoint. Okay, they both overlap everywhere in space. Anywhere in space, there will be electric field produced by Q1 and Q2, and you have to add them up using vector sum. Okay, so let's try to determine the direction of the electric field produced by Q1 at midpoint, and also determine the direction of electric field produced by Q2 at the midpoint. Okay, Q1 is a positive charge, so the electric field produced by a positive charge is pointing directly away from the positive point charge. So pointing away over here means by it's supposed to be pointing in this direction. So I'll call this E1 to signify that it's the electric field produced by Q1. Okay, you want to write E1M also, okay? It means by it's produced by Q1 at the midpoint. That's fine as well. Okay, so Q2 over here is a negative charge. Negative charge will produce electric field, which has direction pointing directly towards the point charge. If it's a negative point charge, the electric field produced by this negative point charge will be pointing directly towards the negative point charge. So towards means by it's in the same direction as E1 just now. So you should expect another electric field over here, which we label as E2. Okay, so these are the two electric fields that we can find at the position right in between Q1 and Q2. And now they ask you to find the magnitude. They ask you to find the direction. So well, magnitude is just the same thing. Since it's produced by a point charge, you can just find it using E1 is equals to KQ1 over R square. Okay, you can put R1 square, R2 square over here just to differentiate, but since it's a midpoint, it's just 0.15 divided by 2 for R. Okay, so Q1 it's 2.0 times 10 to the power negative 7. R square, R is 0.15 divided by 2 square. Okay, divided by 2 because you're asking for distance from here to here only. Okay, so if you perform a calculation, I believe you are able to get 3.2 times 10 to the power of 5 Newton per Coulomb. Okay, E2 is equals to KQ2 modulus R2 square. But since you know that K1 is equals to Q2 modulus, because they both have different sign, but if you modulus it, they will be the same value. And you also know that R1 is equals to R2. It's just midpoint, right? So R1 and R2 should have the same value. Therefore, you can infer that E2 is actually just equals to E1. Therefore, E2 is equals to 3.2 times 10 to the power of 5 Newton per Coulomb. Okay, so now you can proceed to find the electric field at the midpoint. Electric field at the midpoint. Okay, so you can see that at the midpoint, both of the electric field produced by Q1 and Q2 are pointing in the same direction. Therefore, you can just add them up. If they are pointing in opposite direction, then you have to take one minus the other one. But for now, they are in the same direction. So you can just take E1 plus E2. Okay, so you get 2 times of 3.2 times 10 to the power of 5. So you get 6.4 times 10 to the power of 5 Newton per Coulomb. Okay, so that is the magnitude. How about the direction? Okay, if you think about it, right, actually there's a possibility that this answer can be negative. I mean, for this E midpoint over here, let's say if E1 and E2 are in opposite direction, then it will be negative E1 plus E2, or it will be E1 minus E2. Then there's a possibility it might be negative. So actually what you should be doing here, right, you should be labeling this as the X component. Means by you label that, let me write it nicer. Okay, because just now I mentioned that magnitude must always be positive. But here, this calculation here, there's a possibility that it can be negative. So what you're calculating here is not the magnitude of electric field at midpoint. What are you calculating here is the X component of electric field at the midpoint. So you define here to be the X component. You define here to be the Y component. So what are you doing right here? It's you're finding the X component of midpoint. You take what's pointing in the positive x-axis as positive, what's pointing in the negative x-axis. If it's pointing in this direction, then it's pointing in the negative x-axis, then it's negative. So over here, since E1 and E2 are both pointing in the positive x direction, so you add them both up to get this positive answer. Okay, so if it's one of them is pointing in a negative direction, then you have to put negative E1 plus E2. Then there's a possibility you might get a negative answer. So if it's a negative answer, that means it's pointing in the negative x direction. If it's positive answer, then it's pointing in the positive x direction. So this is the step that you should actually go through. You should add on an x down here to show that it's the x component, not the magnitude. Because magnitude of a vector must be positive, but this calculation here, not necessarily positive. It has to depend on where is E1 and E2 pointing and whether E1 is larger than E2 or the other way around. Okay, you gain more understanding on this once you get familiar with what is magnitude, what is component, and what is vector. You have to be clear with the symbol that you use. Okay, so you are done with the magnitude. You still need to not done with the magnitude. This is just x component. But since there's no y component, so this will straight away become the magnitude. Okay, actually I'm slightly overcomplicating myself, but technically what you should do after that is you should take E, let me just write it as mid. you should take E mid x plus E mid y, just like what you usually do. You combine it using Pythagoras theorem. But since right now E mid y is 0, because there's no y component, so you get back just be equals to E mid x square and square root. Therefore, it's just equals E mid x. Okay, so the magnitude and direction, let's just write it straight away. The magnitude and direction, the vector E at the midpoint, the electric field at the midpoint is just 6.4 times 10 to the power of 5 Newton per Coulomb. And in this case, you might be tempted to write what degree, 45 degree above x-axis, or what is the degree over here? Well, they don't even tell us whether it's aligning on the x-axis, y-axis, or front back, or what. They don't tell us the orientation, so you have to give it in the way that that is always correct no matter what is the orientation. Okay, you know that if you arrange Q1 and Q2 like this, the electric field is still pointing towards Q2. No matter you switch it like this, it will still point towards Q2. You switch it like this, it will still point towards Q2. So the most general accurate statement to describe the direction it's pointing towards, okay, or you can say pointing directly towards, pointing towards Q2, okay, or pointing directly away from Q1. Okay, you cannot say to the right, you cannot say upward, you cannot say downward, you cannot say to the left, because they don't tell you how they arrange the charges in the first place. They just tell you that they are separated by 15 cm. Okay, so that is what you need to be careful about. So this whole process over here gets you the first answer. The second thing is, what is the magnitude and direction of the force on an electron placed at the midpoint? So what happened over here is, I hope orange you are able to see. Orange you are able to see. Let's get green. Okay, let's say you put a electron at the midpoint. Okay, electron is placed at the midpoint. What is the force experienced by the electron when it's placed over there? Okay, you know that at this point, midpoint over here, okay, I shouldn't call it. Okay, so if we simplify the situation, it's like this. This is a point that is called midpoint. Okay, and at this position, you have already determined that the electric field is pointing in this direction, that is directly towards the charge Q2. Q2 is purple. This is what you know right now. Okay, technically Q1 and Q2 is irrelevant for the situation right now because you have determined the electric field. But you know that the electric field is pointing towards Q2. And now what they're asking is, since you know the electric field at that position, what will happen if you place an electron at this position? So since it's an electron, it's a negative charge, you should directly know that the force is opposite the direction of the electric field at that position. So the force will be pointing directly towards Q1. Okay, that's the direction. But what is the magnitude? You have to determine it using the formula we mentioned just now. So force, okay, this is question 2. Force is equals to who is experiencing the force? The electron is the one that interacts with the electric field. The electron is the one that is experiencing the force. So here is the charge of the electron. Okay, then multiply by E. Okay, do notice that I still put modulus over here because F here is the magnitude of force, E here is the magnitude of force. So both force and field are vector, so magnitude of a vector must always be positive. So since F and E must be positive, Q here should also be positive value. So we have to absolute value the Q over here to avoid either F or E becoming negative. Okay, so what we obtain later over here, what we need to put in over here is just the value without the sign. So we just need to put in 1.60 times 10 to the power negative 19. This is in your constant sheet. E over here is the electric field that you determined just now, 6.4 times 10 to the power of 5 Newton per Coulomb. And since you can key into your calculator and you get the answer to be 1.024 times 10 to the power of negative 13 Newton. So this is the magnitude. Again, we want the magnitude and direction, so write it in vector form. Write the magnitude, then bracket behind, write the direction. The direction you know is opposite the direction of the electric field, so it's pointing directly towards Q1. Okay, if you are worried that you don't have any working to prove that it's pointing towards Q1, you can say electron is a negative charge. Okay, thus the force experienced by the electron will be in the opposite direction of the electric field E midpoint. You can write like that straight away. Okay, the electron is a negative charge, therefore the force experienced by the electron will be in the opposite direction to the electric field E midpoint. And because E midpoint is pointing directly towards Q2, that's why the force is pointing directly towards Q1. In the opposite direction of the, yeah. Okay, so everything here should make sense. I hope you are able to see here. The question number 1 here, it's focusing on the step 1. Since we say just now a 2-stage process, right? So this is stage 1. Q1 and Q2 are producing an electric field and they overlap at the midpoint. And to determine the electric field, you find the electric field produced by each charges, then you sum them up by considering the direction. That's what you do in the first question. For the second question, you already know that there is an electric field at the midpoint. You are investigating what kind of force, what magnitude and direction of force will be experienced by a charge if you place it at the midpoint over here. So it's a second stage already. As I said, the charge producing electric field is the first stage. A charge interacting with an electric field, thus experiencing a force, is the second stage. So over here, it's a second stage where you have a charge interacting with an electric field, thus experiencing an electric force. Okay, not many people explain in terms of 2-stage process, but I hope if you are able to visualize it that way, right, then you know what formula it's relevant to what situation. And I think that's quite important to understand. Okay, so that's all for this question.